Hi guys. Hi guys. Today's daily Leetcode problem is maximum profit in job scheduling. As we can see that it is a hard problem, but it is an easy problem here if you know some things here. That's it. And when we go to the problem statement, we have n jobs where every job is scheduled to be done from start time to end time. Like there are certain intervals of start time and end time here, and with the in that interval there is a profit also, profit of I for the job. So you're given the start time, end time, and profit arrays. Arrays are given for you. Return the maximum profit you can take such that there are no two jobs in the subset with overlapping time range. So you have to choose such jobs. You have to choose jobs such that your start time and end time interval should not match with the another start time and time interval, right? Like if we say it in a shortcut way, like the interval should not overlap with each other. So we have to find the maximum profit you can obtain by doing this case. So before solving this problem, and I want to share you a problem where we can take a reference of it. So there is a problem called activity selection problem here, and it is a similar problem like a maximum profit in job scheduling, but we have to find the maximum profit there, but we have to find the maximum non-overlapping intervals in this problem. So like see, along with the given set of activities, along with the starting time and finishing time of each activity, find the number of activities performed by a single person, assuming that a person can only work on a single activity at a time, right? So at a time, in a sense, now the intervals which are given should not overlap with each other. So like when we have this input and when we observe this output, like these are not overlapping with each other, right? So when we so this is the sub problem we have in this in this problem, right? So taking reference of this sub problem in this problem, we have to solve this problem. I will be posting this I will pin this problem in the comment section below. Okay. And like when we go through this problem, we can solve this in two ways. Like one is the DP way and another is a binary search way. Like the most optimal problem is the binary search way. And coming to the DP problem, so this is the DP problem I did. Like this is the DP problem which is of n square, which is of n square, and I have taken a class pair here to iterate over the class pair. Uh, like I have stored and have taken start time, end time, and profit of the job in a single pair, and I have considered this. Okay, and I have stored in the list here, and have did one thing here. Like this is the main important thing here. This is the sorting thing. We have to sort the list according to the like increasing order of the starting time here, increasing order increasing order of the starting time in the DP. Okay, and we have taken a DP array here like of length n and n plus one. Okay, and have I've filled the DP with minus one here, and have the recursive solution here, and this is the recursive solution. And like what I'm doing is like this is a just a snack problem like kind of thing, and I'm considering. So I'm just what I'm doing is like I'm just considering this problem, this profit as into my solution, and I'm not considering this profit as into my solution. These are the two cases I'm using in the recursive solution here. I'm considering it, I'm not considering it. I'm at last I'm doing the maximum of A and B, like with the consideration how much profit I get, and with not consideration how much profit I get. With the when I do the max of it, I will get the maximum value, right? So this is the DP solution here. Like this solution is like n square solution and big of n approach. And if you see here, it's memory limit exceeded here. So we have to optimize this solution here. Like we have to optimize this solution. So same here. This is the binary search solution here. Like this is an n log n solution here, n log n solution, and log n, not log n, big of n space complexity here. So I have considered a class pair, like I said before. I have stored the job properties in single pair, like the starting time and end time and profit of the job in a single pair, and I have stored them in the list and have did. Now I have sorted according to the increasing order of their ending time. So in the previous set, I have sorted that in an increasing order of the starting time. Now I'm sorting it in the ending time. Okay, and I have considered a DP to store the maximum profit along the way. Okay, and at first I'm storing the DP of zero with the profit I have made from the first interval. Okay, so I'm running a for loop with from 1 to index last. Okay, and this is the main step here, and I'm finding an index binary search where, so I'm finding an index where, so um, from index where my uh, if is there an like if I consider this ith index, I'm considering whether there is an index where my mid of end value is lesser than equal to my actual index, like actual index value, actual starting index. So when there is an index, then I can say that, like for example, like when we sort this array, like in the increasing order of this time, and 1 comma 3 comma 50, right? 50 and 2 comma 2 comma 4 comma 10, right? And 3 comma 5 comma 40 and 3 comma 6 comma 70 here. Like, so I'm doing in the binary search between, like, for when I consider the I as one here, like I am here and I'm checking whether there is an interval where my ending time is lesser than equal to starting time. So that's it, right? So for a non-overlapping condition, it should satisfy that the my ending time of one interval should not match with the starting, should not be greater than my starting time of the interval, right? So so if we consider here, like if we consider one here, like I'm searching for an interval where my ending time is lesser than equal to my starting time. So if we consider here 0 to 1, I'm searching the index, right? So from 0 to 1, the mid value is this only. So when I consider this, when I observe here, like one thing, like there is an index, ending index is greater than 2. So here the solution here, I won't get an index, so in this case I get an minus 1. So when there is a minus 1, same as this, I'm just including my profit here, and I'm just excluding my profit here, like the previous profit which I made from here. So when there is a minus 1 not equal to minus 1, when the index is not equal to minus 1, then there is a valid interval there which is not overlapping with each other, so I can consider the profit along the way. So I can include this profit into the include variable here, and I will just do the maximum of include comma previous profit. So I can make a track of the maximum profit I made along the way in the DP here. Like, so at last we can return the maximum profit at the end of the At last we will get the maximum profit. What is the maximum profit at the end of the DP, right? So at the end of the DP index, I'm just accessing this maximum value here. So this is the solution here. And yeah, the main step here is to just sort the pair list according to the increasing value of the ending interval. And this is the this is the n approach. I'm traversing along the pair list and searching for an index where there is a non-overlapping interval in the leftmost side of that index. That's it. This is the solution, and this complexity is TC complexity is big of n log. Okay. Yeah, that's it. And login for binary search, and as we are traversing here, this goes to uh, login. Login, yeah. And space complexity is big of, as we are using DP here, so for that extra space we are using. So this is the solution. Thank you.